Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important electromagnetic theory, that is from the dielectrics. In the dielectrics, there is a beautiful concept is there. That concept is the bound charges. Here two varieties of bound charges is there. One is bound surface charge density, another one is bound volume charge density. So, based on that I have to take this question. So, once you have to see, in just 2015 there was a question, that question is a bound charges question. When they are asking, just 2015 they are asking this question. A spherical shell of inner and outer radii A and B. So, first you have to write the data. Whenever we have to take, first we need to write the data. A spherical shell of inner radius A. So, that is the inner radius a spherical shell of inner radius A and outer radius B respectively. So, this is the spherical shell. A spherical shell of inner radius A and outer radius B respectively is made of a dielectric material. So, this spherical shell is made with whom? This spherical shell is made with dielectric material, it is made. Now, the frozen polarization they are giving. So, what is the polarization? P of r is equal to k by r into r cap, because it is a polarization is a vector. So, where k is the constant, where r is the distance from its center. So, find the dielectric, find the electric field. We need to calculate the electric field at where? At A is less than R is less than B. At A is less than R is less than B. Suppose you have to take it is a R. Here we need to calculate the, which one we have to calculate? Electric field we need to calculate. For calculating this, first what we have to calculate? We need to calculate first charge, bound charge we need to calculate, electrical field bound charge. So, therefore, the first step you have to see, first you have to calculate, the first step is you have to calculate the bound charges you have to calculate. In the step A, you calculate the bound charges you have to calculate. So, in the bound charges, two varieties of the bound charges are there. The first one is surface bound charge density. The surface bound charge density is equal to P dot r cap, which is equal to, first you have to see here, your P is equal to, what is your P? Your P is equal to, they are giving k by r into r cap. Suppose you have to take here at r is equal to a, your sigma b, it will become, how it will become? At r is equal to a, your sigma b it will become, so P dot r cap is equal to plus k by a into r cap, you have to get it, k by a into r cap. So, that is the plus k by a you have to write. So, which one we have to write? It is plus k by a, correct. So, at r is equal to b, there is a induced polarization can happen. So, therefore, minus k by b into r cap, we need to take minus k by b we have to write. So, this is the bound surface charge density. Now, we have to calculate the second one. So, volume surface charge density, what is the formula? So, the divergence of polarization, the negative divergence of polarization. So, which coordinates they are? Their coordinates are a spherical polar coordinates. Which coordinates you able to take? Because our system is spherical shell, that is why you have to use spherical coordinates you have to use. What are the divergence of a spherical coordinate? Minus 1 by r square into dou by dou r of 1 by r square into dou by dou r of, which one we have to use, that is the dou by dou r of r square into p you have to use. What is your p? Your p is equal to k by r. So your p is equal to k by r. This r get cancelled. Therefore you able to get it as a k you have to take outside, k by r square, which is equal to rho b is equal to dou r by dou r get cancelled. Therefore you are getting, that is the k by r square we are getting. This is a bound volume charge density. So after finding the bound volume charge density, we need to calculate the third one. So our ultimate purpose is electric field. That's why first you have to calculate the charge enclosed, bound charge you have to conclude. So bound charge up to where you have to see, you have to take it as a, the inner radius of the spherical shell is A, the outer radius of the spherical shell is equal to B. So therefore you have to take the bound the charge up to the r we need to calculate. So this bound charge is the combination of two. So what is that combination of two? Sigma b into dA. This is the surface surface integral. This one is a rho b into dV. This one is a volume integral. Now you know that. So what is your surface integral? You know the surface integral. What is your surface integral? Sigma b is equal to, you have to take it as a minus k by r, because within the up to the a only you have to take. So at a, how much you have to get it? Minus k by r, you have to take it as a minus k by r. So integral dA is equal to, which one we have to write? It is r square sin theta d theta d phi, r square sin theta d theta d phi, which is equal to, so this is the surface integral. So the element of area element of a spherical coordinate. Now you have to write it is the volume integral. You have to write it is rho b is equal to, already we calculated, minus k by r square. Rho b is equal to, what is that? Minus k by r square. Your limits up to where we have to take a to r you have to consider. Your limits are a to r you have to take here. So your limits you able to take it is a only you have to take. So otherwise you have to take your so this is the r square, r you have to take. Your limit is 0 to a you have to take. 0 to a you able to take that one. So therefore minus k by r square. So volume element of that 4 phi r square into dr. Now you able to see, so 1 r get cancel, 1 r get cancel. Therefore minus 4 phi k a you able to get it. So which one we are getting? Minus 4 phi k instead of you have to take that one. So we need to consider as a 4 phi k a you have to take because it is 0 to a it will come. So plus 0 to a means you have to take it as a k by a, you have to take, this is the a square you have to take it is. So 1a get cancelled, therefore minus 4 phi k a you able to get. So those are the integrals, you remove this one. So integral 0 to 5 sin theta d theta, integral 0 to 2 phi sin theta d theta, you able to get this one 4 phi k a it will come. Minus you have to take it as a minus 4 phi r square get cancel. You able to get it is minus 4 phi k into, you have to write it is r minus a you able to get. So therefore what we have to write it is minus 4 phi k a. So minus 4 phi k r. So minus into minus plus 4 phi k a. So 4 phi k a, 4 phi k a get cancel, minus 4 phi k r we are getting, which is equal to, that is the bound surface charge is equal to QB is equal to, we have to get. So, that is the value minus 45 kR we are getting. So, what is our ultimate goal? So, which the boundary? So, for A is less than or is less than, A is less than or is less than B, for A is less than or is less than B, we need to calculate the electric field. How we have to calculate the electric field? 1 by 4 pi epsilon naught into the bound charge, so is divided by R square. Now, you substitute here 1 by 4 pi epsilon naught into what is your total bound charge? The total bound charge minus 4 pi kR is divided by R square. 1 R get cancel, 4 1 ja 4 1 ja, 5 1 ja 5 1 ja get cancel. Therefore, minus k by epsilon naught into R cap we are getting, which is equal to, this is the electric field. What is your answer? Your answer is minus k by epsilon naught into R cap. Once you have to see the answer, so what are the your answer? Plus k by epsilon naught is R is not correct, minus k by epsilon naught into R cap. So, option B is correct, option C is wrong, option D is wrong. Like this we have to solve in our competitive exam. Why I have to take this one? Here all the formulas should cover. So, we need to know the electric field, we need to know the QB, we need to know the sigma B, we need to know the rho B. That is why I took this formula. So, entire the bound charges is covered. So, that is why I have to take this formula. So, try to do here. So, if you really likes my teaching, we started the CSIR and GATE physics content we started. So, there in our app JL physics and DL physics also available. So, this is our Quantum Online Academy app. So, once you have to download your Play Store of the Android mobile phone. After downloading, you have to log into our app. So, once you have to log in, so many courses will display. So, based on your caliber, based on your requirement, you have to negotiate with me also. This is my personal mobile number 9908437460. You can contact me, and later you have to purchase the course. So, the courses will display in our app CSIR and GATE physics course, and JL and DL physics course, and mathematical methods of physics. It is completed. Individual papers also is there, CSIR and GATE mathematical methods of physics, entire syllabus, entire portion is available. And classical mechanics, so this classical mechanics also completed, this paper is completed, entire classical mechanics is one course is available. Now, we started the electromagnetic theory. So, maybe so tomorrow we have to finish the electrostatics, almost finished, electrostatics almost finished. Now, we have to enter into the magnetostatics. So, almost 30% of the syllabus of the electromagnetic theory. So, we are finishing. So, this course is every day morning 6 a.m. to 8 a.m. In between the 6 a.m. to 8 a.m. there is a live class is there. So, there is a live plus recorded classes are available. Live plus recorded classes are available in our app. So, if you have to purchase, so the link will so automatically will open, and so you able to see the courses. So, once again I am appealing to you. So, please share and subscribe our YouTube channel, and you have to inform to your friends also. Thank you so much.